visual understanding of lower and upper bound of a sequence. In this tutorial video, we are going to discuss about the idea or the concept of upper and lower bound of a sequence. Before that, let's discuss on the idea of bound or limits, okay, in real life as well. Bound. So when we talk about bound, it has a sense of restriction, okay, it has a sense of a limit, okay, it has a sense of limit. Look at this house. As you can see, if you have someone here, okay, this someone is bounded up by, as you can see, by ceiling, right? It is bounded up by ceiling, which means you never go above the ceiling. The same is true here, and bounded below by the floor, okay, bounded by the floor here, okay. So there is a kind of bounding, there is a kind of limitation here. The same is true here, the fence, okay, the fence. So if we consider here, we have two boundaries, okay, maybe the floor, or let it be the wall maybe, okay, and then the fence. We also have a fence here. Lots of bounding or limits. Okay, let's bring this idea or concepts to the sequence. Okay, let's bring it to the sequence. All right, so we have different sequences, but we're gonna focus on the boundary one, the one which is bounded and monotonic. So let's define first. Let's define a sequence. We have a sequence n sub n. Okay, start from 1 to n. We usually strict this n is elements of positive integer, but in real life, in practical life, we do also have negative integers. Okay, we also have a situation or physical phenomena where the sequence goes to negatives. Okay, just keep this in mind. All right, this means this is a set of sequence where let it be a1, a2, a3, a4, it's and so on and so on. It's go on up to an. Okay, up to an. Now let's bring the boundaries here. Okay, this sequence has a boundary. This is bounded by here u. Okay, I'm gonna take this because I use u to mean or from the upper. Okay, this sequence is bounded by, limited by u. Okay, therefore we are going to say that u is greater than or equals to every element, each element of the sequence, which means I can write this as a7. Okay, this subscription n start from 1 up to n, every element. Okay, now let's do another one. This sequence is again bounded by, let it be bounded below. This one is like a floor, bounded below by L. Okay, this is to mean lower, from lower. Okay, lower, bounded by this. So which means that L should be, as you can see, is always less than. Okay, L is less than or equals to each or every elements of the sequence an. Okay, an up to n. Okay, let's visualize this on a number line. Let me use a number line. Draw a number line. I want you to pause the video and try. Always think of the limit, upper and boundaries, upper and lower boundaries. Okay, let me use this one. Okay, so since we're using monotonic, if it is either increasing or decreasing, okay, a1 on a number line, if I write it this one, a2 is obviously greater than a1, a3 is greater than a2 and a1, a4, and so on. Okay, the first thing, I use the number line, which means it has a sense of infinity and negative infinity. Okay, without any limits. Number line, a line. So I'm gonna use again use here u as an upper bound and this as the lower bound. Okay, so upper bound is always greater than every element inside. the sequence, and lower bound is less than every element here. Okay. The same is true when you're using x and y axis. Okay, in 2 dimension on a plane. That is 1 dimension. This is 1 dimension. Now I'm gonna use 2 dimension. Okay, let's have some kind of sequence here. I don't have the sequence. Let's have the sequence, and that sequence is bounded above by this line. This is upper bound. And then we could have, for example, when it is n1, you could have this one, n2, you could have this one, this one, this one. It's kind of increasing, or it could be decreasing also. It could be decreasing. Let me use, it could be kind of this sense. It could be decreasing. Anyways, in both cases, it is bounded, or the floor is here. Okay, this sequence never goes above the upper limits. And then let it be this sequence has also the lower limits here. Okay, lower limit. Let the lower limit is here. This is the lower limits. Maybe the sequence closer. Okay, maybe it's close to, this is the lower limit. It may close to the lower limit. Also, it may close to the upper limit, but never go beyond that. Okay, this is the idea of upper and lower bound. Okay, let's see one example. Okay, let's see just one example. I'm gonna take one of the sequence. Okay, and that would be a sequence which is represented by 1 over n. Okay, 1 over n. Let this one is 1. Okay, let's see. Let's interpret the property here. Okay, so when n is 1, 2, 3, 4, 5, and so on, what will happen to 1 over n? Okay, so when 1 over n, okay, let me use some kind of space here. 1 over n is 1. Okay, 1 over 2. Okay, 1 over 3, 1 over 4, 1 over 5. Okay, what do you notice here? What do you notice when n goes to infinite or huge numbers? Okay, it's kind of decreasing. Every time it's decreasing. Every time it's decreasing. Okay, so let's represent this on a number line, or before that, okay, let me represent this on a number line, and then we'll see how it goes. Okay, let's see. When it is 1, okay, let me have here 0, let me have here 1. Okay, so it's going to be decreasing, right? Half. The first is half. I mean, the first is 1, the second is half, the third is 1/3. Okay, and 1/4. As you can see, it's close to zeros. 1/5. 1/5. So it's approached to zeros. Approached to zeros, close to zeros, but it will never be 0, because there is no value of n. There is no value of n that gives you zeros. You never have these cases. So your graph, maybe your sequence is close to zeros. Therefore, we can say that this is the lower bound. Okay, this is the lower bound. How about the upper bound? Okay, now we stop here at 1, right? Because we use n as the initial. Okay, we start at 1. Therefore, we are going to say that this is the upper bound. Okay, our upper bound will be 1. But the point is, when you're asked to write the sequence, okay, especially the set of upper bound and the set of lower bound, you are going to use infinity and negative infinity. What did that come from? Where did that come from? And why we say that this is the least? Okay, where are the others? Okay, and this is the greatest of lower boundary. Where are the others? Therefore, in order to visualize that, we have to continue. Okay, we have to, since our n is elements of positive integer, let me take the half here. Okay, let me take when n is half. When n is half, when n is half, okay, let me put it here. When n is half, okay, the value of 1 over n goes to 2. Because 1 over 2 is going to be 2. So when n is 1/3, okay, the value of n goes to 3. Therefore, it's going to be here, I have 2, I have 3. Therefore, I have a lot then. From those, 1 is the least. Those are an upper bound, but the point is above the ceiling, okay, above the limits. So since we restrict ourselves from up to 1 and then we ignore the rest, therefore in this case the our upper bound is 1. But from all the upper bounds, as you can see here, it goes to infinity. From all upper bounds, 1 is the least. Okay, 1 is the least. That's why we are saying the least upper bound. Let's see here, the same is true here in case of -1. Because instead of using positive integer, as I have told you in physical phenomena, we can also have negative integers. So when you use negative number, for example, if we have -1, okay, if we use negative, let it be -1, okay, so it's going to be 1 over n is going to be -1, okay, so we have -1, -2, it's just the same is true here, okay, we have -1, we have -half, okay, from the left also it's close to zeros. It's close to zeros. From the right, from the left, it's all close to zeros. Therefore, as you can see, all of them below 0 are less, or the least numbers. Okay, therefore we can say this 0 is the lower bound, but that's the greatest lower bound. Okay, so the greatest lower bound in this case is 0. This is the idea. So when you are asked to write the set, so we are going to use -infinity to 0, including, and the upper bound, the set of all upper bound, including 1 to positive infinities. Okay, this is the reason behind. Okay, I use a number line. Let's use the axis, the plane. Okay, let's visualize using a plane. Okay, let the horizontal is represented by n, okay, and the vertical is 1 over n. Okay, from our discussion we had here 1, okay, we have 1, and if it is 1, let it be 1 is here, so this is one of the point. When it is a 2, okay, when it's 2, it was half, okay, it was half, so we have here. And if it is 3, okay, we're gonna have 1/3, okay. So from this, when n is getting increase, okay, 1 over n is decreasing, okay, decrease to zeros. All right, so from this, our upper bound, upper ceiling in this case is 1. So upper bound is 1. How about the lower bound? The lower bound is getting zeros, it's getting to zeros. It's approach to zeros, but never touch the zeros, because as I have told you, we don't have value of n that makes it 0. Okay, it's approach to zeros. Therefore, the lower bound lies here on the x-axis. I mean on the n axis. Okay, so our lower bound is here then. The lower bound is zeros. Let's see if it is greatest and the least. Okay, as I have told you, when n is half, okay, let me use half here. When n is half, okay, so the value of 1 over n, like 1 over 2 is 2, it goes to 2 here. When n is 1/3, okay, it goes to third, which means when n goes to or close to zeros, okay, when it is close to zeros, the value of n gets bigger and bigger and bigger. So this is kind of what we have, but the point is it's above the limits. Therefore, we are going to ignore that and then take in, as I've told you, in real life, we can have those phenomena. Anyways, for this case, we start n as from 1. Therefore, anyways, we have a lots of upper bound here. From those 2, 3, 4, 1 is the least. 1 is the least. And then the same is true here. You can have -1 here. When n is -1, the value of 1 over n is -1. Okay, let it be -1 here. When n is, let it be 2, -2, the value will be -half. Okay, all right. So when n is, for example, 1 over 2, -1 over 2, -half, okay, it would be 2 here. Okay, -2. So it has sorry, when I draw it, I made a mistake. It should be here instead of this point. Okay, so it's kind of going this way. Okay, but the point is, as you can see, we have 0 here, but those below 0 are less. So when we compare from negatives, 0 is the largest, so we can say that 0 is the greatest lower bound according to these graphs. Therefore, that's why we're saying the greatest and the least. This is how you are going to visualize. So this leads us the concept of even limits. Limit from the left, from the right. When we approach the ceiling, what will happen? Okay, when we approach to the limits, in this case the lower limits, what will happen? As you can see, it goes to negative infinity. Okay, when n goes to bigger and bigger, okay, it's going to be close to 0. But when n gets to negative, when n gets to like zeros, it goes to negative infinities. Okay, you never touch zeros. Therefore, instead, it's going down to negative infinity. Okay, this is the idea of the greatest lower bound and the least upper bound. In the next video, we'll see more practices, different sequences.